right. Good afternoon, everyone. I hope you're all having a wonderful day wherever it is in the world that you are. Today we're going to be doing some soldering streams. And I've got some kits that I'm going to be working on. And the two I hope to get through today is the eLearnTronics resistance and the capacitance kits. So we're going to start with the resistance one here. I'll set this one over here. And these are just really basic electronics kits meant to teach the ideas of how you do these kinds of things and how resistance works. So let's go ahead and pop this open. Oh, okay. This is a lot smaller than I thought it would be. Okay, and here's our board, which is kind of cool. Got a little bit of glare there, but it's already pre-tinned out and ready to go. It has the voltage and the electronics calculations on the back. And then there's a very handy dandy little calculator placard that we're going to be using here. So I'll set that over there. And I'll go ahead and put that box over there out of the way. Let me go ahead and get these parts sorted out. So we have our board here. And let's pop open the remainder of our kit. There we go. Lots of parts. Okay, cool. We'll put that in the box and set it aside. Okay, so what we're going to need to do first here is sort out all of these resistors by their colors. This is our plug. We're going to set that aside as well because we're not going to need it right now. This is for connecting to our plug. We also will not need that. These are the screws for our feet, which holds the whole thing up, which we're also not going to need right away. So we're going to set the feet and the screw pegs aside. There we go. And then we've got our on-off switch, which we're also going to set aside. And then we've got a number of LEDs with the anode and the cathode, the positive and negative, and you don't want these to go in the wrong direction or else it will not work well for you. Okay. Set all of our LEDs up here, ready to go. And we might do the LEDs first, we'll see. Okay, set that up there as well. So the next thing we're going to need to do is organize all of our resistors. And we have, I think, 8 resistors here that we're going to need to sort. And the resistors are organized by a color band that is on the resistor itself. And it doesn't matter which direction the resistor goes in, that's not important. But it will go right up in the top here along this area. I've got a little bit of glare still. Right across the top. And different resistances will give more or less power. So if there's higher resistance, then the light should be a lot dimmer, essentially, is what's going to happen there. Okay, cool. So let's go ahead and start by organizing our resistors. And these are really tiny, so I'm going to bring over my magnifying glass here so I can see what's going on. And this one looks like it is gold is the first band, or is that brown? We're going to go by our little chart here. 5-band code, yes. Oh, you know what? My overhead light isn't on. That's probably why I can't see things as well. There we go. Now we can see things really well. All right. Okay, so that one, this looks like it's red first. So this would be a last band is gold. Okay, so that's the tolerance. Perfect. So this is red, red, orange, and then the last band is gold. So red, red, orange is going to be 2, 2, 3. So 22 times 3, 220. I think that's 2.2 kilo ohms. Red, red, orange. So I also have on my computer here a handy dandy little calculator, just in case I got lost, which I am. So I'm going to go red, red, and then orange. And the last band is gold. So this one is actually 22 kilo ohms. So we're going to put this on our board here in the 22 kilo ohm slot, which is right here. And we'll go ahead and bend these leads so that it nicely fits. And we're going to orient all of these so that the reading is from top to bottom in the orientation that we want. So this one is 22 kilo ohms. It should fit right in there. There we go. We'll pull that nice and taut there. And we'll take the back and we'll bend these sort of out of the way so that they are ready to be soldered. Perfect. So there's our first one in, red, red, orange, and then it has a 5% impedance. So we're good there. Let's do this one next. This one is red, 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 it looks like, with a gold at the end. So let's see what the red, red, red one is. Red, red, red is going to be 2.2 kilo ohms. So we will go ahead and drop that in the 2.2 right after I bend the leads again. Okay, there we go. Perfect. Oh, my neighbors doing their thing. All right. So we'll go ahead and put that right in there. And make sure that that's nice and tight in there so it's not going anywhere. Perfect. And we'll bend the leads out just like the other one. Okay. All right, perfect. So that one's in place and ready to be soldered. Okay, let's move on to the next one. This one appears to be gold? It looks like yellow, black, red, maybe? Can't really tell with that one, so I'm going to skip it for now. This one's more obvious. This one is orange, orange, brown. So, going by my guide, that is 3, 3, and then 1. So it should be 33 or 330. So orange, orange, brown. Yep, 330 ohms. Perfect. So that's actually going to be first in our entire nest right over here. Sorry again for the background noise. Okay. And we'll just bend those in and right there. Perfect. Making sure I keep my same setup that I want there. Okay. So that's 330 ohms. And we'll bend the resistance or the leads out of the way. Okay. 330 ohms. Orange, orange, brown. Okay. 470, if we wanted to calculate 470, it would probably be yellow, purple, and then something else. Welcome in, Maui Game Studio. Thank you so much for the raid, buddy. How are you doing? We're having some fun today with some electronics work. Thank you so much for visiting. Hopefully you can hear me okay. If you can, I'd appreciate a heads up. Let me give you a quick shout out here. All right. Out to Maui Game Studio. Please give them your love. Maui Game Studio is a game developer on the island of Maui, and they make the game Familia, which you can get on Steam. I do have a copy, and I intend to play it at some point. I've just been trying to find the time. How was your stream, bud? All right. So 470 is going to be yellow, violet, and then I think it's going to be brown at the end. So we want to find yellow, violet, brown. And that might have been the one I was just looking at. Is this yellow? That certainly looks yellow, violet, brown to me. Stream was good. Tell me if you're ever going to play so I can update. Oh, absolutely. right, so this looks like my yellow, violet, brown. It's hard to tell the color is an exact match, but it looks pretty close. All right, yellow, violet, brown. So that should be my 470 ohms resistor. And if I was smart, I would have a little overlay here to show you all how you calculate resistance, but I do not have that set up for this really kind of jank setup that I'm using right now, so we'll just make it work. All right, and then we'll have to bend these out of the way, just like that, so those leads are good to go. All right. Yellow, violet, brown, that looks pretty good. So next, let's try and find our 1 kilo ohm resistor, which is going to be brown, black, and then probably orange. Let's see here, brown, black, orange. This looks like it. That is definitely brown, black, orange. So, yeah, brown, black, and then orange for the multiplier. Cool. So that should be our 1 kilo ohm resistor. Okay. And the game, while I'm putting this together, the Familia is only a couple hours long, right? It's not like crazy long, because if it is, I might just do a quick stream at the start of the year to, we'll welcome that in. All right, there we go. Bend that, whoops, let me get that lead nice and out of the way there. Okay. All right, so we've already got 4 of our resistors here and the 5th one over here. Some people play for a really long time because there's roguelike content. Oh, I didn't know that. Okay, cool. All right, so we've got our 4 resistors. We only got 3 more to go. The next one is 4.7 kilo ohms. So it's going to be yellow, violet, and then orange, I think. So yellow, violet, orange. This definitely looks like it is yellow, violet, orange to me. So we're going to call that good. Takes most people about 3 to 4 hours to the main storyline. Okay, so it would probably take me 2 weekend streams, since my weekend streams are about 2 hours. And then I could play through the main storyline. But I am definitely planning a stream of that. Okay, yellow, violet, orange for 4.7, right? Yellow, violet, orange. Is that blue? That does not look blue to me. Yep, yellow, violet, orange. Okay, cool. Some people literally played 100 hours of endgame comment. Oh my goodness. I don't know if I would subject everyone watching to that, but I would definitely be interested in playing that. Okay. The yellows are kind of subtle. I think it's hard to see that it's yellow. Yellow, violet, brown, yellow, violet, orange. That one looks like it's all reds. Is that what it's supposed to? Yeah, 100 something. Okay, good. All right, we have our 10 kilo ohm resistor. So 10 is going to be brown, black, and then yellow, I think. Or brown, black, orange. I don't know which. I think it would be brown, black, orange. And this looks like it is brown, black, red. And this one, 47 kilo ohms, is going to be yellow at the start. Yellow, violet, and then yellow, violet, red. So this one times 100, 47 times 140, yeah, 47 kilo ohms, I think. Oh goodness. I need to go to my calculator to make sure I'm doing this correctly. So 10 kilo ohms. If we do brown, violet, red, or brown, black, red. Let's do that. Brown, black, and then red. And that's 1K, not 10K. is what it's telling me. So something isn't quite adding up. Brown, black, red. It says that's 1K. Maybe this is my 10K over here. Red, red, red. No, brown, black, orange is 10K. Okay, I probably got those backwards. It's a good thing I'm double checking my math here. Yeah, brown, black, orange is 10K. So that means this one needs to come out. This is why we're double checking this. My resistor math is not amazing. Come on out. Okay, I actually have pliers for this, so let me get those really quick. Make my life easier. Where are my good pliers for plucking things? Sure, these will do. Perfect. Okay. All right, we got pliers, so you can just take those and yoink, right like that. Easy peasy. Okay, and then we want to put these back in the 10K because I got the numbering wrong. That's why we're double checking this. Brown, black, orange is 10K. There we go. Brown, black, orange is definitely 10K, and brown, black, red is 1K. And that is going to be this guy right here, brown, black, red. Okay. Brown, black, and red. I know this part isn't terribly interesting while I'm getting it all set up, but don't worry, the payoff is going to be kind of cool, I think. Okay. Okay, brown, black, red. All right. And that brings us to our last one, the 47K ohm resistor, which looks like it is yellow, purple, red. So let's calculate that real quick. Yellow, purple, or violet, red. And that one looks like it is 4.7K. So I think I've got my yellow, purple, violets mixed up. That one's yellow, purple, orange. So we're going to swap those two as well, because I think that this one should be at the end and not where it is. So we'll pull that out real quick. Yeah, because this one's orange, this one's definitely orange. Okay, so yellow, purple, orange is going to be the 47. Yeah, okay, this one goes at the end. So up this way and right on in. Here we go. Whoops. Come on, go in the little lead, please. Thank you. Okay, there we go. Much better. And I don't want these leads to break, so I got to be careful. Because if they break before I solder them, that kind of defeats the whole purpose. Okay. Looking good. All right, last one then is going to be the yellow, purple, red one, which will be my 4.7K. Yeah, 4.7K. Perfect. And then we'll go back and we'll double check all of these just to make sure. Because the last thing I want to do is find that I soldered these all wrong and I got to desolder something, which is never fun to do. All right, let's get that nice and on there. Perfect. And come on. Bend the leads back. Like that. Okay, great. So now we've got all of our resistors in. I'm going to clip the board here really quick so I can just go through and double check everything on my color chart. So orange, orange, brown should be 330K. So we'll double check that real quick. Orange, orange, brown. Yeah, 330 ohms. Not even K, just ohms. And then, whoops, come on. That's not what I wanted to do. I wanted to tilt you upward, please. There we go. get the light on there well so I can see what's going on. All right, that one is yellow, purple, brown. So yellow, purple, or violet, brown is going to be 470 ohms. That's correct. 1K ohms is going to be brown, black, red. So brown, black, and red is 1K ohms, so that's good. Then red, red, red should be 200 or 2.2K ohms. So red, red, red is 2.2K ohms. We're good there. Whoops. You know, this whole thing just getting in my way. There we go. Now I can see better. All right. The yellow, violet, red should be 4.7. And I do have 4.7, so 2.2 to 4.7. And then brown, black, orange. So red, 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 orange, orange, orange for the last three, that's good. Brown, black, orange. And then orange is going to give me 10K ohms resistance. And then red, red, orange should give me 22K resistance, yes. And the last one, yellow, violet, orange, should give me 47K ohms. Okay, we're all set, so that looks great to me. So at this point, I believe that we are ready to go ahead and solder some stuff. So let me go ahead and turn my soldering iron and let it warm up. Okay, it's powering up. So we're going to flip this over. And we are going to solder all of these individually across the back. And I'm just going to make sure that they're nice and tight on there. We're not going to have any wiggles. Okay, we're good there. All right, my soldering iron is warmed. And now the fun begins. We're going to scoot this a little closer to here so we don't end up biting ourselves or inhaling any of the fun vibes. And we're going to turn on our fan, and I've got my solder here ready to go. So I apologize for the noise. That's going to be a little loud. And now we're going to just prep our soldering iron first by getting a little bit solder on the tip, like that, and cleaning the tip. So we've got a nice shiny soldering tip now. And now all I need to do is, before I do that, I'm actually going to attach a second holding hand to this so it can take a little bit of push when I put pressure on it. Okay. And the tip looks good. So we're going to go ahead and solder. Ooh. Okay, that's a good clean joint there, perfect. It probably needs a teeny bit more on the top one. There we go. And a little bit more on the bottom one. Okay, that's kind of falling through for some reason. Let me... Hold on just a sec, I gotta take a look at what's going on here. Why are you just kind of... Oh, it's all bubbling up on the other side. Goodness. Well, it's creating a joint. It's just not like the clean joint that I want necessarily, so I may try and clean that up afterwards. For now, let's go ahead and do the remainder. All right. Clean that tip. That ball of unnecessary solder on there. All right. Get nice and warm and doop-de-doop. Cool. Okay, great. So of note, whoops, the last time I did a soldering stream, I didn't calibrate my soldering iron beforehand, which is a problem. So because I didn't calibrate it, I was having to hold the iron on there for a really long time, and I couldn't figure out why. And it turns out it's because my soldering iron was way too cold because it wasn't calibrated correctly. So, come on. There we go. Get nice shiny peaks there. Okay, awesome. Get that into the thing over there. Okay, a lot of this is sinking through when I'm doing it, so I'm a little worried that I may need to clean up the far side a bit, but we're doing what we can to make it good. So now the soldering iron is actually hot enough and not cold like it was last time. And so the soldering is going a lot smoothly. More smoothly, rather. Okay, come on. There we go. Okay, that should be done on that. I'm gonna inspect my work really quick here. And yeah, I can see where some of them are not really great. I'm gonna redo a couple. And if we flip it around, we're gonna see that the beading up on the other side is probably pretty thick on some of these. Yeah, that one pushed up a little bit, unfortunately. So we may try and fix that. Yeah, that one beaded up a ton right there. Maybe I should have soldered it on this side instead of the back side, and those at the end need a little bit more. So we're going to redo, I'm actually going to try and pull up some of the solder off of this here really quick. And I have a nice little tool now. I didn't have a pen for this previously, but now I do. So this is going to make things a bit easier to use. And I need to actually... Hold on a second. There we go. Just need to put a little bit of that on there and we'll wick that solder right off. Perfect. Okay. Get that excess going away. There we go. Okay. That looks a lot better than it did. Okay, so we just need some solder there and there, I think. Yeah, right there. Okay. Ugh, I gotta clean up my sponge. All right. I also need to resolder my tip. There we go. That's better. All right. Much better looking there. Wow, that's really flowing through. I need you to go all the way in, please. Thank you. There we go. That's better. Okay, and we do need just a teeny bit more here. Okay, that's better. Okay, let's take a look. Okay. And yeah, I'd beat it up on the other side for that one. You can see right there specifically the beating up. I don't know if I can hold this a little closer and you can see better, but yeah, right around there. Anyway, we'll clean that up as well really quick, and we want to add a teeny bit more solder because these through holes are pretty big, it feels like to me, for the work being done. All right, back on you go. I feel like that's just continuing to build up more than I want. Right? Yeah, it's beating up on the other side again. I'm gonna leave that one alone, I think. It's just becoming more and more burnt out, and we'll clean that one up a teeny bit, because we don't want a big bulb going on. Okay, perfect. And then we solder our tip just to make sure it's got fresh solder on it. Okay, and then we're going to turn off the fan and turn off our soldering iron. Okay, so we're done with that part. Now we're going to clip all the leads, and we're done with the first part. I have a new shiny pair of clippers here, which are really nice, made specifically for this type of thing. And I keep all the leads just in case I might want to use them for something later, for other little small projects. It's nice to have them around. All right, that's really nice. All right. The board says, Viva la Resistance. Very appropriate, given the purpose of this project. All right, and get right under there, please. Perfect. Okay. Cool. Okay, almost done clipping here. That one's kind of big too, but whatever, I'm just making it work. Okay, so our first set of work is done. We've clipped all the leads, and we now have our resistors attached to our board and ready to go for the next part. So the next part we're going to do is we're going to be putting in all of our LEDs, and we have 8 of them to do. And I'm just going to double check the LED orientation really quick for the project. So give me just a moment to look this up, and we'll figure out what the LED orientation needs to be on this. So yes, here we go. Okay, instructions for the resistance board. And we're going to look at those PDFs really quick. There we go, perfect. Yeah, 1 circuit board, barrel jack, 9 volt, 4 standoffs, 8 LEDs, 1 switch, and the appropriate resistors. Okay, Place the leads, turn over, touch the iron. Yep. Carefully push the component. Remelt. Oh. Okay. Sure. The leads have an anode and a cathode. The anode is the long side. The anode goes in the top. Okay, perfect. So with all LEDs, there is a long side and a short side. Again, known as the anode and the cathode. And it's, I don't know if you can see against this very well. I'm going to try here. Yeah, there we go. So this would be the anode and the short side would be the cathode. And the positive side is the anode. The power needs to flow through that way, or else you're going to get magic smoke, and we don't want magic smoke. So we're going to avoid that problem. And we're going to drop all of our LEDs in, and then we're going to go bend the leads appropriately. Okay. All right. Hey Art Sci-Fi, how's it going? Good to see you on the stream. Sorry if you just got caught in an ad, but it will be done in a few minutes. Oh, it'll be starting in a little bit, so it hasn't started yet. Welcome on in. Thanks for stopping by. We're just doing some soldering projects today. I'm practicing my soldering and learning some basic electronics in the process. It's something that I've always been curious about and, have wanted to know more. And I've done some soldering projects on the channel before, but they were more basic than this, I would argue, except maybe one of them was a little more complex, but that would be the, I think I have it sitting here actually, that would be the die rolling kit project, which was this big boy right here, which when hooked up to power rolls 2 6-sided dice, which is kind of a cool project. But I don't have it plugged in to power right now, but I might show it a little later. I'll set it back on the side over here, out of the way. And right now what we're doing is we just finished soldering all of our resistors here, and we're going to go through and do all of our LEDs now. And I just put all the LEDs on the board, and now we are going to flip this over while holding the LEDs in place, and we're going to bend the pins so that they are out of the way. And I want to make sure that my anode and cathodes are good on all of these, and it looks like they are, so we should be doing okay there. All right, this is a little funky. There we go, that's better. I'm going to do it from this angle. Sorry you won't be able to see much while I'm doing this. It's just the process. All right, there we go. And this just kind of holds things in place so that when we turn things over to solder, it's not going to fall out on us, essentially. Okay, there we go. Also, thank you so much for the follow. It's greatly appreciated. All right, there and there. Okay, so those are all pretty much in place, and they're not going to fall out on us, although they are kind of falling down. So I might try and hold these up a little. Let me see if I can do this a little tighter, because that is really not... actually, let's do this. I'm going to do this instead. We're going to clip this in place. There we go. And we're going to use this handy-dandy little tool that I have here to try and bend things more nicely. Yeah, it's not great, but better than it was. Okay. Okay, there we go. That's a bit better. I'm just going to see how far these are falling. Yeah, they're kind of dangling pretty far, so maybe I need to... I would like it if they sat flush when I actually solder them. So we'll see what we can do about that. Maybe I can kind of... No, that's going to be awkward to do from that angle. Maybe I can just rest it flat against the... That would be smart. Haha, problem solved. just get this out of the way for now and do it flush against the board here, which kind of is working how I want it to, maybe. All right. Maybe if I do it this way instead. Is that going to hold? No, not really. Well, we will do one at a time, and we'll try and make sure that it is held nice and flush. Maybe if I bend this and then I kind of... There we go. That's a bit better. And then bend it tight against the thing. There. That's what I like. Okay, I'm going to rebend all of these because I think that appears to be holding it much more flush than it was. It's not falling out now. Okay, we'll do that for each one of these really quick here. So I take this and then rebend it close to the thing. I got to really get my finger in there to get the point of the bend that I want, and hopefully without destroying the lead in the process, because it's still got to be in there. Is that better? It's a little better. Well, we'll do one, and then we'll move on to the next one, I think. We can do that really quick. Okay, let me take a look at turn my soldering iron back on here. And go ahead and prep it up. All right. It's not quite hot. I gotta wait for it to heat. Okay, now it's hot. Perfect. So we'll bring this back in here because it makes it a little easier to see what I'm doing. And bring that up like that. Perfect. And let's rebend this. Should hold flush, all right? Don't have enough hands. That's part of the problem here, right? Okay, let's rebend this up. Oops, get you out of the way, please. Let's rebend you up. Bend this out of the way. So I want this flush. There we go. There, that's a lot tighter on there. Perfect. All right, we'll go ahead and do that one. Oops. Right after we drop it. Okay, cool. All right, let's re-tin our soldering iron. Where's the... Okay, that's happy, and let's go ahead and solder. Come on then. There we go. Okay. Good. Let's take a look at how that looks on there. Yeah, we're looking pretty good, and it's at a good... It's not perfect, but it'll do. I'm happy with that. All right, now we'll rebend the next one. Oops, don't do crazy. What are you doing? Oh my gosh. Okay, good. Right, flush, please. Okay, there we go. Okay. next one to solder. Oops. Is right here. And the reason I tin the soldering iron each time is because it helps with the heat flow to the surface of what it is that I'm actually soldering. There we go. Okay, perfect. Going to take a quick look. That is a little high off the ground there, but you know, again, this isn't meant to be perfect. I'm just trying to get as close as I can to what I would like it to be. All right. So hold that in place and we'll bend that over at a good angle. And do the same thing with both sides of this, please. Come on. There we go. Relatively good enough. Yeah, I've given up on this being super tight to the board at this point. It's okay. Things will go onward. Oh, got a little bit of splash there. Okay. Okay, good. Also good. Okay. Getting nice little peaks there, and you can kind of see up close what we got going on. And if I rotate this away so you don't get as much glare. Yeah, I don't think there's really getting away from the glare, unfortunately. But you can see as we're starting to make some good connections here. There we go. Now you can kind of see better. All right. And we got this one to do next. Okay. Oh, whoops. I don't want to bend that. That could result in bad things happening. Okay. Okay. Onward we go. To the next one. All right. Okay, that's not transferring heat for some reason. Let's get some more there. Okay. You don't want to lift the pad on accident. There we go. Thank you. That would be bad. There we go. Okay, come on. Thank you. Okay. Oh, there we go. Okay, this one's definitely a bit looser. Those are looking good. So let's just re-tighten this one really quick. And we really want to get it bent like right there. I can't really bend with this very well. Wrong pliers. I should probably use a different set for that. But if I can get my finger in there, which I am, And that appears to do a pretty good job. Nice and flush, right? All right. There we go. That's a lot better. It still seems a little loose to me. That will have to make do. Okay. A little more of that. This goes back on. Retin the clean and then retin the tip. All right. Okay. Perfect. Voila. Looking really good and shiny. Okay. And I want to comment that I haven't really, I'm not professionally trained to do this. I haven't taken any classes or anything. This is all just self-taught. All I did was buy some kits online and try and teach myself, messing around, making mistakes. And I've definitely made mistakes. But it has been a good process on learning how to solder in the first place. There we go. That one's pretty good now. But, that's just kind of how it goes. Gotta be willing to try to make mistakes if you want to do cool things. Okay, cool. And what I do have going on here is a fume extractor to pull the fumes from the solder, and it's not really the solder as much as it's the flux in the solder that's causing the fumes. And that's what causes it to chemically bind. Everything together. And you don't want to inhale that. It's a bad idea. So we're not doing that. Okay. That looks good. And our front pads are looking pretty good too. Everything's nice and solid up there. And this isn't moving very much, so I think I'm just going to give it one last little adjustment here so that we're solid on that. There we go. And I know I'm blocking this from the camera. Sorry, it's just the angle's a little awkward. And so I have to do that in order to really see what I'm trying to do here. There we go. Okay, that's better. And I think we can just go straight through and solder those last. That one's still really loose. Hold on. I'm not so happy with the bend on that. Can you please bend closer to the... There we go. I think that's better. Certainly looks better. Nope. Having some trouble with this one, I apologize. All right, maybe I have another pair of tweezers I can use to bend this more easily. Got thick, flat tweezers. Yeah, here we go. Okay, we want you to bend right at that angle, please. It's nice and taut to the thing. Thank you. Oh, and I just broke it. So that was what I was a little worried about. It'll still solder because there's enough there, but I definitely bent it a little too far. So what we're going to do is we're going to solder the far side, and I'm going to try and prop it up. I might be able to, yeah. We'll see. That's what you get for bending it back and forth too much. Okay, no worries. We'll make this work. I'm just going to have to really be careful about how I get this done. Okay. Disaster strikes, but we move through anyway. Let's ignore this. Okay. Okay, good. Okay. And then we can go right into the last two because I already prepped those earlier. So there we go. Okay, and the last one. Okay, we're all set on that. Just right. And we'll have to take a look at this and make sure that it actually... Yeah, I think we're okay. I think it actually bound to the metal there and didn't just make a pool. All right, we got some nice shiny stuff there. So let's grab our snips and go ahead and remove all of the leads that we don't need anymore. And we got to be careful not to get it in our face. There we go. Good old side snips that we just got. Okie dokie, there we go. Oops. That was pre-snipped. Saved myself a step there. Okay, and then the far side. Okay. Actually, if I flip this around, it'll be easier. Okay. It's nice having these good side cutters now, because previously I was just using a random pair of snips that I had, and they didn't really get flush. So these are actual good flush cutters, unlike the previous pair. Okay, so our LEDs are in, our resistors are in, so now all we have to do is attach the power. I'm just going to go right here. Not the power on switch is going to go right here, and then the power connector, which is going to go right there. So we can go ahead and prep that really quick here. I'm just going to take a moment to glance over at my phone. We're doing good. Okay, cool. All right, so we'll go ahead and attach our power, which really can only go on one way. And it doesn't matter if it's up or down, it just flips the switch. So that's all set there. And this one I am going to have to lay down flat so that I can get one good thing on there. Let me double check the instructions just to make sure I'm not missing anything here. Yeah, we do the anode, the cathode. Okay. LEDs, now solder the switch. Doesn't matter which direction. Okay. Now place the screws and then add a battery. Cool. So we're almost done with this first one. That's going to be pretty cool once it's done. So I am going to have to hold this in place. Can I clip it in place, maybe? I think that would be the easiest way to do this. So if there was a way I could just clip it. Let's see here. Not so much. Ow. Because, yeah, it's just going to fall off otherwise. Can I rest it on top of this one? So that it kind of sits and holds it in place there for us. Yeah, that kind of works. Okay, there we go. The back end is a little loose, but let me tweak this slightly. As long as it's not falling off, that's all I really care about. I think I can rotate this to do that better. There we go. Okay. These helping hands are very important for making your life easier, for sure. Okay. I think we're good there. We got it nice and flush on the front side? I think so. Not quite. I could sit and fiddle this all day. So let me just try and get a nice... Oh, I know a good way to do this. Hold on a second. I have a method that I can use that is a solid one to get this to stay in place. I just got to get one of these little things on here. There we go. Now it's staying on there. Okay, turn this back on. And we can actually take this and put a little bit of flux on there. It'll help out with things. Okay. Oh, whoa, that put a lot. Let's not get that on our hands there. Well, just a sec, I gotta dry this off my hands. Wash my hands in a little bit here. Okay. So we just want a bit of flux on our pad here. And we're going to rely on this to do a lot of the work for us. There we go. And what we're going to do is we're actually going to get a bead of solder on our tip here, like that. I'm going to clean off so that I have good conductance. And then I'm just going to heat this and boom. Come on. Okay. Through the magic of the soldering iron, it is done. Okay. Let's take a look at how our switch did there, and it did not do great. It's kind of off kilter, so I may heat that and push it in a little. So let's see if I can do this really quick here. Get my helping hand so that I can heat the backside and push it in a tad. This thing is all over the place. There we go. All right. All right, and we want to heat the backside of this so that I can push it just a little bit here. My overhead light went out. That explains a little bit as well. All right. Okay, I'm going to call that good for now. It's not perfect, but, you know, that's just the way it goes. So this is our last piece, which is our dipole power here, and that goes on just like this, like so, and it's very large, so this is going to take us a bit of power to solder, because it's big, and it just rests right there, like that. And I am going to put some more flux on this one so that it will be happy. There we go. Okay. Okay. Next, please. Thank you. Oh, come on. Get hot, please. Okay, pull away. There we go. Okay, I need some more of this. Whoops. There we go. Okay. Okay, let's take a look at how that worked. And if that looks good, might need a little more. That one looks really good. That one looks kind of weak. But that one looks okay. So we'll add a teeny bit more onto this one here. Okay. Get that out of the way there. There we go. Okay, that's better. Okay. And I think we're done with this. I'm going to turn off my soldering iron here. And we're going to take the board out of our helping hands. And we'll attach the feet as it directs us to. Yeah, we get a nice attachment there. Cool. So to attach the feet, we need to take the feet over here, away from all of my clipped pieces of metal. And the feet go on the back, and the little attachments go on the front. So right through there, and then nice little standoff so it doesn't have to sit on the table. So you get a little bit of clearance there, which is a nice design thought in my opinion. That's well thought through. All right. There we go. Just some simple little PC standoff screws so that it doesn't have to sit on the table. So this is meant to be a display of Ohm's law, which is how you get current based off of voltage supplied and resistance. And the voltage supplied in this scenario is a 9-volt battery. And then you take the voltage and you divide it by the resistance, which is going to be our 330, 470, 1K, 2.2, 4.7, and so forth. And then you get the actual current in milliamps because of how small our amounts are here. All right, and then screw this on just like that. All right, so now we have our little board with its nice little standoff. We've got our resistance learning board. I'm just going to make sure that it's actually visible here. Hey, how's it going, Tough Like More? Thank you so much for stopping by, and I'm going to rotate this in ways so that you can actually sort of see what's going on here, hopefully. I think I need to, whoops, sorry. My stream display lags slightly behind what my phone shows. There we go. So we've got the whole board here with all of the resistors on it, and everything is all hooked up. And if we flip it to the back side, everything, whoa, and then we drop it, of course. Everything is nicely soldered and ready to go. I think that is good, yeah. Get a little closer there so you can read the text on the back. Viva la résistance. All right, so let's go ahead and take this and let's hook it up to some power. I've got a handy dandy little power adapter here, and I've got a Duracell battery, no particular endorsement there, it's just a battery. 9-volt battery ready to go. So I'm gonna hook it up to my whole thing and we'll plug it in. And provided that it actually does plug in, there it goes. And moment of truth, we're gonna turn it on and boom, look at that. And this is how we display resistance Duracell battery. Not a sponsor at all. Yeah, exactly. Maybe if I turn the light off really quick, you'll be able to see it a little better. So let me turn the lights out just so you can kind of get a good look at this here. There's the other light switch. Okay, there we go. So you should be able to see now the resistance. And from left to right, we have very little resistance to a very high resistance. And the higher resistance, the less power that ends up going through to the LED. And this is basically how electronics determine, how much power gets to the thing that you're trying to power, which is a fun little lesson to learn. I am still working on the actual math part of this, but I think it would be really fascinating if I were able to, sit down and learn the math behind all of this, which is something that I'm still working on. So yeah, now we have a cool little display board that shows from low resistance all the way to high resistance. And low resistance means more power gets through to the LED, and high resistance means, less power gets through to the LED. It is a cool little board. You can get these from a company called eLearnTronics. Again, not sponsored. I just happened to get them because it was a holiday gift for me last year, birthday gift this year. And I've been teaching myself to solder and do little electronics projects, and so I thought that this would be a fun way to get acquainted with, the basics of electronics. So this resistance board is learning, or this project is learning about resistance. So I'm going to go ahead and turn this off. I'm going to set this to the side, because now we have another project that we have some time to work on here. So let me go ahead and pull that project out here. That was our first one. This one has to deal with capacitance. And my understanding, and again, I am not at all trained on this or anything along those lines, is that capacitance has to do with building up and then releasing energy in a electronics project. And so you want to have capacitors, and these are some pretty big capacitors, so that you can reliably have only a certain amount of power coming through on your board. So the capacitor basically makes sure that it's going to build up to a certain amount, and then it'll discharge the power that it has, and it won't discharge any more than that. And that's essentially how the capacitor is supposed to work, is my understanding. So I've got my board here. This one actually has far fewer soldering points, so it shouldn't take us as long to build. I'm going to set the battery out of the way here, ready to go. And we're just going to go ahead and get all our parts out here and get right on started. You can also see my prior learning to solder projects on my YouTube channel, which is linked underneath the stream. If you are curious and want to know more about other fun little soldering projects that I've done in my process of learning how to do this. And the idea of doing these simpler projects is I'm working my way up to a fairly complex one, which is a full-on Bluetooth speaker kit, which I'm looking forward to making. The most complex one I've built so far is this puppy, which when you turn it on, it flashes the LEDs, and then when you press the button, it essentially gives you a value of 2 die 6 or 2 6-sided dices if they were rolled. So that's the most complex one. It has a lot of really fine solder points with some ICs, integrated circuits going on here, some capacitors, lots of resistors, and a couple of, a bunch of LEDs and a couple of diodes to help run the whole thing. That one took me quite a while to get going. So let me sort out my parts here. I've got one LED on this project, nothing too crazy there. And I've got, ooh, these got a little bent. I've got a number of really high, big capacitors here. There's a 1000 microfarad, a 100 microfarad, I believe. Is this 100? Yeah, 100. And a 470 microfarad. So we'll set those aside over here. Actually, I'm going to put them up here so they don't roll all over the place. Pardon the bugs. My garage is open, so I wouldn't suffocate while I'm working on this. We have one resistor. And we have our standoffs, which I'm going to throw over here. And we have our screws, which I'm also going to throw over here. And then we've got an actual push button for this project, which I'm going to throw here. And we've got a dip switch, which is going to let us select which one of the capacitors we're using. And then we've got our power. So let me pull up the instructions for this one, because I don't want to make mistakes or assumptions on how this should be done. Okay, that's the LEDs. Oh, that's the this resistance. Okay, let me pull up the capacitance board and its instructions. And this one doesn't look like it actually has paper instructions. It looks like it's all video, which isn't great. I would prefer if they had paper instructions. So let me get my helping hands here. And for this one, we're going to be doing capacitors, but we'll start off with the small components first, because they're the trickiest, and we have our resistor here. And based on the math from our project that we just finished, this one looks like it is let me pull up my magnifying glass so I can actually see what I'm doing, and turn my overhead on so I can also see what I'm doing. And it looks like this is let's see here, a yellow, purple, red. So that tells me it should be a 470. Is that a red or a brown? Let me compare it to this one. Maybe I can see the color better. It looks more like brown than red. So yeah, I think this is a 470 ohm resistor because it matches this 470 ohm resistor that we already have on this project. So I'm going to say this is a 470 ohm resistor with some confidence here. So we're going to take our protective paper ends off, and we'll set those aside. We don't need them anymore. You'll be in and out, no problem. Thank you so much for hanging out, Tech Life. I appreciate it. And also thank you so much for the follow. I appreciate that as well. Let's see here. So we're going to do this resistor first, because it's basically the one piece that we know is going to go there. There's no real question. That's exactly where it's supposed to go. And for simplicity's sake, we're going to make this as a left to right. So we want the resistor to be red from left to right with the yellow, purple, brown bands, which I really don't know if you're going to be able to see this very well. I'm going to try and get it up there for you all. Yeah, more to that side, thank you. Yeah, there you go. Yellow, purple, brown. I bought one of those solder kits that tests resistance and it tells you what it is. I should get one of those. I actually do have a, what's it called? A multimeter. So I can actually test resistance if I need to. I do have my multimeter here. I just don't have it hooked up at the moment. And I'm trying to do this as much as I can without having to rely on the tool itself if I don't need to. But if I actually wanted to, I could pull out the multimeter and actually measure the resistance with that. And I should probably practice that. I think I'll go through later on this board and check the resistances of all of them and just see what it measures. It's only a 5% gap there, so it's not going to be amazing. Okay, so we got our first resistor in here. And let me just bend the pegs back. Okay, that's nice and solid on there. So we'll go ahead and take this, we'll flip the board, and we'll go ahead and solder, which is always my favorite part. All right, let me turn my soldering iron back on, let it warm up real quick. Do I need to do a surface mount? I have not yet done SMD soldering, and that's one that I'm working up to. There is one, not even one, there's a number of SMD components in this project that I aim to do. Oh, let me see. Am I still live there? Okay, yeah, I am still live. It looks like my player load, my video feed on my side just stopped working. But yes, I have not yet done SMD soldering, and the big project that I'm working up to does have SMD components. It has something like, I don't know, 60-something SMD LEDs and then a couple SMD chips. And I'm kind of nervous about that one. But, you know, that's why I'm practicing, is to work my way up to that sort of thing. So let me turn my soldering iron and fan on. Let me retin the tip on my soldering iron here real quick so that it is nice and happy. And that looks good to me, nice and shiny. So let's go ahead. And actually, I want to put this down really quick and shift this over. I want to do this sideways because it's easier to get at the components that way. Okay. And I'm going to have to retin the tip. Yeah, that's not great. Let's just do that real quick there. Okay. And the whole purpose of me learning to do all this stuff was because, one, I was curious and I just wanted to try. And two, I'm interested in doing video game repairs. And so I have some old Super Nintendo carts and other things that I want to replace the batteries on. So that is the whole purpose of doing this. There we go, one done. And two done. Okay, no problem. Go ahead and clip those leads if this looks good. Yeah, that looks really good. Cool. Probably a little much on the flip side. I hope it didn't damage anything, but it should be okay. The mount holes on these projects are really big, and so I'm noticing that the solder is like going through instead of staying on the side where I'm doing the work. But you know, that's just how it is. All right, flush cutter, do your thing. Perfect. All right, and another flush cut there real quick. Okay, so we got our resistor on. Now let's do our LED. And the LED, I'm going to assume that is the anode and that is the cathode. It doesn't really have an anode cathode, but I'm assuming top is anode and bottom is cathode based on the flow here. Yeah, because that's coming from the power and that's going to the, yeah, okay. I'm assuming this is right. They don't really give any indicator that this is how it should be. Tall. There we go. All right. What's the soldering iron? I have a Kesker that was a gift to me from a good friend who is one of the folks who hangs on the stream from time to time, Chris. And his buddy Pete And so it's a Kesker T12 soldering station. So it's just really basic, nothing special. And then I've got a Hako tip going on it. I'm using the what is it? The T12 D16 tip, which is kind of a wedge tip, not wedge, but just kind of a simple little thing that gets the work done. Doesn't need to be super complex. I have a couple other tips as well. One's that's supposed to be made for drag soldering. Haven't used it yet. Haven't practiced drag soldering yet. Gonna need to learn it if I'm doing SMD stuff. I'm pretty sure. So I'm a little apprehensive, like I said, but that's why we're practicing with the simpler stuff first. Oh wait, before I solder this, I was gonna check and make sure that I actually have the orientation correct. Let's see what this video says. This is a 17-minute video. We're gonna go through all the components. Yes, we're gonna start putting the components in maybe. I'm just skipping ahead. Okay, they put the resistor in, so that's good. I'm following that part correctly. And the LED. Oh no, he's putting the button switches in next. Okay, let me skip ahead to where the LED is. There's the LED, okay. No, that's that step. All right, yeah, you have the dip switch in, I see that. You soldered the dip switch. You haven't done the LED yet. Come on, where's the, okay, there's, no, that's the dip switch. Oh, he does the LED like way later. Maybe I should be doing them in the order that they're doing them. Okay, yes, that's the anode. Just show me which direction it goes in, please. Yes, I recognize that that is the anode and that is the cathode. Please skip ahead to the part where you actually put it in the thing, yes. You've got a Penicil Digital. It's a TS100 clone, but uses USB-C for power. Oh, got it, okay. All right, so he's putting it, oh, you hit it underneath the, oh my goodness. If you flip it over, will I see? Yeah, it looks like that's correct. It looks like yeah, I think that's correct. Okay, so that definitely looks like I'm just gonna watch this really quick here and make absolutely certain before I go and do this, because the last thing I want to do is find out I put it in wrong and then get magic smoke. Okay, yeah, that looks like the anode and cathode are correct. So if that's the bottom of the board, go away, please. He's got it flipped, so the short side is on that side. Right? Right. Okay. Let's get this soldered. A little bit much solder on there, but it's all good. Okay. Nice. That really got right on there. Perfect. Okay, awesome. Snip that. Okay, I'm actually going to listen to what he says in the video really quick because, again, I don't want to end up doing this wrong and letting the magic smoke out. Let me turn the volume up on this really quick and apologize for the background noise.
So, yep. Here we go. So we'll just stick that in there. Which way we put it in. With
Yes.
the LED, it does matter. Now, the best way to figure out the correct way to position this in the board is to find the flat side of the LED.
Oh, there's a flat side to an LED?
And it's pretty easy to see, but then if you look at the silk...
There's a flat side to an LED apparently. Okay, that's something I didn't know. Oh, it does have a flat side. What do you know? I learned something new today. Perfect. Okay, we're good then. I'm going to go ahead and clip these leads. Haha. Learning new things. Perfect. Okay, clip these leads. Yes, please. And right there, please. Okay, cool. So next up, we need to do our dip and pin switches. So let's go ahead and do the actual pin switch, which hopefully will just kind of fit on there without too much. Oh, it is going to require a bit of bending, I think. So let's, there we go. Oh, come on, no. You don't want to. Okay, I see now why this is. Okay, let me remove this and I'll bend these legs, these leads out just a tiny bit here. There we go. That's better. Okay, perfect. Aha, much better. Okay. Yeah, I don't want it to, it's doing exactly what I'm trying not to do. Okay, let me see if I can fix this here real quick. I want you to push down more on that side, please, if you would be so kind. Yeah. Okay, there we go. There's not a lot of through on this lead at all, but as long as it's in there, I can work on it. Okay, that's flush, and it's in there so solid it's not going anywhere. So I should be able to solder this pretty quick. Okay, let's get my helping hand back in here, and we'll do the soldering. Okay, cool. So, fan on, soldering iron hot, soldering iron clean, soldering iron tin. Oh, no, that's dancing a little. Okay, cool. That one's not so great. Looks like it might be a cold joint. Okay, that one's good. Let's go back and clean up that other one really quick here. Okay, that's better. Cool. All set there. All right, so we've got our LED, our resistor, and now we have to do our dip switch, which is probably going to be the trickiest part. And we want the dip switch probably to just sit nicely like that. Does this have a anode cathode? No, just the line up the holes here. Okay. Is that also going to give me some grief? Oh, no, there we go. Easy enough. Okay, cool. And that looks like it's going to fall out pretty easily though. So I want to be careful about if I let that go, is that going to fall? Feels like it will. So we'll just do this one resting on the ground. Really quick here. Yeah, that's good. Okay. Actually, I'm having a little hard time seeing this one because the leads are so small that I think I'm going to try and get my helping hand in here at least so that I can see what I'm doing while I'm doing this. So just a second while I set this up so I can see the points there really well. Okay, perfect. Whoops. It's leaning over a little farther now. It's like, I can't do this. All right, there we go. That's exactly the magnification that I want. Perfect, thank you. Okay, back on. Okay. There we go. Okay. It's a little tricky of an angle here. There, that's what I want to do. Thank you. Okay. Okay. I thought I didn't need magnification, and I was like, yeah, oh wow. My eyesight's okay, but there's definitely some things that it helps with those really fine-pitched things. And one of these looks a little weird, so I'm going to reheat it really quick here. But the rest look pretty good. Got helping hands with a magnifying glass that has a ring light on it and a microscope. Oh gosh, I've not yet advanced to the part where I'm needing microscopes, but I may one day need to do that because of the, like I said, the surface mount stuff is going to be really complex when I get to it, and I'm imagining that having a microscope for that would make things a lot easier. Okay, there we go. Now I can see what I'm working on. All right. I'm just going to take this one here and reheat it real quick. There we go. That looks a lot better. Okay, cool. I don't know what I'm doing. I just wanted to learn, so I bought a bunch of stuff, then bought a few broken motherboards off eBay to try to fix. Oh, cool. I've not yet gotten to the level of doing that kind of work yet. Okay, cool. So we're done with our... I'm just going to take a close look here. Yeah, those all look good. And the dip switch looks fine on the far side. So now we're getting to the capacitors. And the capacitors, as I recall, only go in one orientation. They also have a anode and cathode, but I don't know how to read the diagram on this. So I'm going to watch the video really quick on the capacitor part. I'm going to skip ahead to capacitors.
Okay, I'm happy.
Yeah.
Barrel jack connector, you want it to be...
No, we're going to skip ahead.
Up.
No, here we go.
Okay, and what's really happening is we have power going from the barrel jack connector to the dip switches.
Yes.
And then those are then running up to, based on which switch is turned on, they're going to the various capacitors to complete that part of the circuit.
Okay.
And the negative side, the dark side on the silk screen, then goes to the negative portion of the battery.
Oh, okay. So the negative is that part. Okay. Right, hold on. This has got like a lot of paper on it that I don't want to mess that up. There we go. Come on. Okay, that's more trash. Where's my side cutters? I can just snip this out of here. Don't want to do something weird where I go to take it off and it completely removes the lead from the capacitor somehow. It's like, what the heck? Okay, there we go. Get all that junk off. We've managed to fix one so far, but I feel like it was sheer luck. Well, sometimes, you know, that's just how it goes. All right. I'd like you to tear off, please. I understand why they put the tape on here to make it easier to work with, but sometimes it's like, okay, look. All right, so the negative and the positive side of the capacitor. Okay. Supposedly this direction. Supposedly. And I'm just going to verify the video again really quick here to make sure which way they put it in. Go back a few seconds, please. Thank you.
Then running up to, based on which switch is turned on, they're going to the various capacitors to complete that part of the circuit.
Okay.
And the negative side, the dark side on the silk screen, then goes to the negative portion of the battery, thus completing the circuit and allowing the capacitors.
Okay, that looks right to me. So basically, we take that and we're going to take this and bend these leads so that the capacitor is nice and happy. And then we're going to solder. My favorite part of the day. Okay. And what I'll do later on is I have some IPA, some isopropyl alcohol here, and I'll go through and clean up all of the stuff that's left behind by the soldering. Okay. All right, one capacitor on. Second capacitor is going to be the bigger boy, which is the 470 microfarad. I'm just verifying the value on it. Yep, 470. Okay. Positive and negative. Come on. There you go. Hi there. And we're going to hold this in place. And bend these out of the way there. Okay, and then more soldering. And again, better safe than sorry. We're going to double check the video and see how they do the next one real quick here. Okay.
Soldering iron on the capacitor. Now we'll go to our 470 microfarad capacitor. That's going to go in the middle. Again, we want the negative side pointed in the same direction.
Okay, yeah, we're good. Oh, whoops. Let me move this whole setup so that it's not going all over the place. Okay. Okay, and capacitors. Okay, and next capacitor. Oh, whoops. There we kind of go. I'm going to clean that up a little. I'm going to get some flux on there and see if we can't clean that up a tad. Okay. Yeah, we're moving that all the way out of the way, and we're going to redo that one really quick. So I didn't like how that looked. Okay, that's much cleaner. I'm happy with that. Cool. Okay, and now the big boy, the super duper gigantic capacitor, the 1000 microfarad. The negative goes to the north. That is really big. These electrolytic capacitors or something else. All right, then we're going to bend the pins out here. Okay, cool. And we'll go ahead and solder that on. Okay. Okay, those look really good. All right, last part, we need to snip these first, so let me take care of that really quick. Oh, it goes flying. Okay. Okay, cool. And we got some spare pieces lying around here. We're just going to toss them there. Okay, last thing to do is our power connector, which we can do really quick here. And we're just going to get the connector in there like that. And be happy with that. Oh, this is really, I forgot. We've got gigantic capacitors on here now, so maybe I should have put the power connector on first. That would have been intelligent to think about. Let me see if I can't figure out a way to just tack that on there really quick. Yeah, let's do this. Hey Queen, how's it going? This seems stressful and sciencey. Well, I don't know about the stress part, but it's definitely sciencey. Having fun. That's for sure. Do I need a little more in there? Come on, pen. Give me more, please. Thank you. Okay, yeah, we can see the good stuff. All right, cool. So I should be able to tack that in place if I just get a little bit on my soldering iron and then just hold it on there. It should just immediately do its thing. Hit go. Yeah, I hear you. Okay, we got a bead of solder. And now we're just going to take this and hold it in place. And that bead of solder should flow in there. Sort of, not really. Not doing what I hoped it would, but it is holding it in place, so we're good enough. All right. Now we'll put this up on the holding hands and we'll actually solder the last part here. Okay, let me get this ready to go. There we go. Fan on. Some on our soldering iron tip there. Clean the tip, and away we go. Okay, that's good. Go at this one from this angle. Right there. Come on. There you go. Okay, that looks good. And last but not least, this one right over here. Come on. Okay, I think that looks good. Let's take a look. Okay, it definitely flowed through on the other side, so I think that the connection looks pretty good to me. Okay, I'm just doing a last check of all the joints here. That one looks like it could use a little more solder, maybe. No, that looks pretty okay. Okay, so now that we're done with that, we can go ahead and put our standoffs on. So we're going to do that real quick here. Big capacitors on this thing. At least big by comparison to most computer standards. Hey, how's it going, Art Sci-Fi? The smoke extractor looks like one of them early 80s Coleco tabletop games. It kind of does. I'm glad that I got it though, because I work in an environment that's just in my garage, and the airflow is okay, but you know, just having the smoke extractor gives me an extra bit of safety, and better safe than not able to breathe, you know. Okay, get this last piece in here. Okay, and then the last foot over here. What are we building today? We built, to start off, a kit on learning about how resistance works. And let me turn off my soldering iron since I'm done with it for now. And what we are now building is a kit that teaches us about capacitance. So this, let me make sure that you're able to see it okay. Yeah, that's pretty little lower there. So this kit has 3 different capacitors on it, and we can use it to see how long it takes for an LED to light up based on the charge time of the capacitor, essentially. And I just finished soldering the whole thing together. So what we're going to do now is we're going to go ahead and follow the instructions. And I'm going to plug in my already connected and ready to go battery here. And the whole thing is off, so nothing's going to happen when we first use it at all. So we'll plug it in. I'm going to turn off my, I'm actually going to, no dip switch pressed, nothing, it just turns right on, right? Nothing happens. Let me turn the light off so you can kind of see what's going on here a little better. So no dip switch is set, the whole thing just immediately turns on. The light just lights up when I press the button, all right? If I turn on the first dip switch, what that's going to do is it's going to tell it to use the first capacitor, and the light stays lit a little bit longer. You'll notice it's still got some power running through that capacitor, just a little bit longer. And if we turn on the second dip switch, because it is also a larger capacitor, it should stay on even longer afterwards. So I get a good like half second of charge from that capacitor holding its charge and then discharging, right? And now, last of all, we turn on the big capacitor. It'll stay on for a long time after the light is discharged, right? It's staying on super long, and I let go, and it takes a really long time to fade out there. So I can also turn on all 3 capacitors, and that's just going to take forever to turn off practically. So it basically shows you how capacitors hold energy and then keep discharging energy when they no longer have a charge. And based on the dip switch settings that we use, we can determine, which one of those capacitors we have enabled. And that is my little project here on, whoops, let's bring this down over here. We can actually be seen there, yeah, on capacitance. And hopefully I can get it to, yeah, you should be able to read the text if I just hold that there. A little more that way. So that's the first project, or the second project that I built. And then the first project that I built was a example on resistance. So let me get that one plugged in here really quick because it has its own interchangeable power plug, which is really cool. And if I turn this on and then I turn the light out again, we're going to be able to see, based on this, essentially how different resistors work. So low resistance all the way to high resistance, and we get a nice little LED effect across the board from that. So only, I believe, 330 ohm resistance all the way up to 47,000 ohms resistance, and then the LEDs light up based on how much resistance you have. And that's pretty much it, unfortunately, that I have time for today. That's all the projects that I have in my phone battery. Unfortunately, I can't have it plugged in and use my headphones at the same time because I do not have Bluetooth speakers on my phone. But that was pretty cool. We built 2 whole projects. We got the capacity and resistance projects done. And next week, Saturday, I will be here and we will be doing 2 other projects, which will be the series, looking at capacitors in series and resistors in series, versus parallel, and how that affects the flow of electricity through electronics. And then we will also be building, depending on how long that takes, a multiplexer, which is going to be really cool, I think, for us to build. I will be putting links to where you can get these products. They will not be affiliate links on my YouTube video if you are watching this on YouTube after the fact. And you can get these and practice soldering yourself. Please do support the guys who make this, eLearnTronics. They're a cool little company. And I'm so happy that they make little kits like this so that people like me can learn about how to make electronics and how they essentially work in making everything inside of your computer do what it does today.